Constellation is a very interesting challenge from an operational perspective, that we're flying today two very different data points. The Shuttle, which is fundamentally a transportation system with that can serve as a very rich platform for doing a variety of operations, but its operational methods and paradigms were set in 1970s aircraft approach in the avionics architecture and grafted on a command and telemetry system to that. Station is a late 90s compute-intensive system designed for long life cycle on-orbit maintenance, and so you could say some of the critical technologies with the Shuttle were high-energy systems. How you manage that, APUs into hydraulics, and as well as the whole rocket thing. Station, the critical technology was quick disconnect connectors. We almost weren't able to launch on schedule because of those. So we use the metaphor of the Shuttle and Apollo for the launch phase as you look at the longer horizons for Constellation, long-term surface operations on the Moon and hopefully Mars. We think that there's much we've learned from the way you operate a transportation vehicle from an infrastructure stably in a hostile environment like Station or like the surface operations. And I would expect, that was something we tried to capture in the book, particularly in the mission planning cycles, because when you're in a place and doing a day of operation every day of the year, that's an entirely different mission planning approach than the Shuttle, where you have X days on orbit and you got to squeeze every bit of operation out of that. It took us a while to make that transition in Station because, to some extent, you do things the way you do it, but just the grim reality of a day of operation, a day of mission planning every day, a week of mission planning every week, 6 months of mission planning every 6 months. One of the things we've learned in studying to look at Constellation is this is the most revolutionary operation we've had to design relative to recent memory, because we return to the Mercury, Gemini, Apollo sequence. Shuttle and Station were designed to be open-ended programs that 20 years from now you have to be able to turn out as good, if not a better mission than you turn out today. Constellation will be relatively brief periods of flying a particular kind of mission, then you stop that because you've got a new vehicle. We fly to Station for a little while, we do some test flights, we fly to the Moon a la Apollo and gradually build up a lunar base, and then you stop those. And so the nature of the evolution of the operation will be as rapid as it was from 1962 to 1972, but we're all a whole lot smarter. We have much better tools, and so the truth is, yes, we will drastically re-engineer the way we do operations for these. These are high energy systems that will spend half of their operational lifetime effectively in a flight test environment. That's one of the lessons of both Challenger and Columbia. Challenger, we didn't learn it quite right, is that these are fundamental high energy systems such as this. You fundamentally fly in a flight test mode. We're not going to fly 60 missions to Mars on the systems we will build the first time we go to Mars. If we're lucky, if we keep going, we will be constantly evolving. And as you can see, a useful metaphor of this John Common Sense document is you build the best possible spacecraft you can, you find it was deficient in some way, and the next one you build is better. And we've been very lucky to have, maybe not as often as I would like, but a new spacecraft development often enough to take those frustrations with the current vehicle, build the next one better. There's a perception out in the world outside of human spaceflight that, oh, those guys in mission control, they just do stuff like they did in Apollo, you know, they did for Shuttle and all that. And we believe that what we have done is tailored according to the program requirements and according to the mission needs. And the station operation looks nothing like the Shuttle, other than, well, there's some trim, casually dressed, smart young people sitting at computer workstations, but the nature of the work is radically different. The nature of the operation is radically different. It's been really interesting. The subject is talking about how the operations on the moon will be similar or different from what we did in Apollo and what we've kind of learned about it. Obviously, what happens on the moon depends on what the mission is, and there's a requirements process that defines what you're trying to do. Obviously, if you look at Apollo, it was, holy cow, just get there and come back safely, and we got a little wait, we'll carry some science along. As I visit with some of the Apollo alumni, we're blessed to have a few of them still among us. They describe a very interesting phase from Apollo 11 on out. Of course, we could talk about the pre-landing missions as well. That once we proved we could do it, the scope of the missions ballooned. That, okay, we can now go and we can carry more advanced scientific equipment that takes a little bit more out of the crew to do it, but let's do that, and let's try to squeeze a little bit more out of each EVA. And of course, we threw the little lunar buggy on there. And one of my friends, who's a fellow worth talking to, a guy named Robert Nute, N-U-T-E, was one of the mission planners. He and a very small group of people did the mission planning, and he talks about, you know, they were just figuring out what's a safe mission for Apollo 11, and you know, how far away dare we walk from the lander, and what can we reasonably expect crews to do. That once they had that success, that the science, the space science, planetary science folks avalanched them with requirements. And where you would say, well, the first thing is scary and it's the mission that oh my God, we did it, then after that it's just kind of turning the crank. The missions became more and more complex, up to the point that well, each mission was more complex and had more challenging objectives, and the job got more difficult. But of course, the job got more difficult as everybody became smarter and had higher skills for dealing with it. The station, because of its complexity and subtlety, and I could say some of its design deficiencies from operability, it's a huge puzzle, complicated by the fact that we have Russian, American, Canadian, soon to be European and Japanese equipment. And we'll say it's a much bigger management problem, we'll say a command rather than a control problem in the military sense. Command decides what we're going to do and how we're going to do it and get it going, and control is send the button to tell it to go do that. In the early days of International Space Station, we spent a lot of time struggling, or not struggling, but figuring out how you will exercise command and control, because from the very first days it was a multinational thing, which is not anything any operator ever wants to be saddled by, as a bunch of other operators operating their stuff, sharing risk over high-risk events, and each providing complication to the other. Operators, we say, we figured out how to operate this, we're going to go do it. And so the International Space Station has been an incredible laboratory of figuring out, you could say it simply, sorting out the command and control. Who's in charge on the International Space Station changes frequently around, say, a shuttle mission. A shuttle is the active vehicle during approach, and it kind of tells everybody else what to do, although station has the ability to tell it, nope, we don't trust you, back off. The Russian and American sides of the International Space Station each have the capability to control attitude, and there are good reasons why one should control and the other at one time and the other another time. And so all of those things are things to be worked out, and at different times a different person in a different control center is in charge of the overall operation. You know, when we first heard about Constellation being an American program, we were all, yay, there's a whole layer of complication we don't have, but the current policy analysis and architectural analysis says the surface of the moon, if we're really going to do the big things, it's going to take other countries joining us. And so, you know, small sigh, but okay, well, we'll get to work with our friend Yuri on a different thing. The Apollo lessons, I think, as operators, the basic core virtues that we forged in particularly Gemini and Apollo about how you deliver a safe, successful mission, that's all been living. We're lucky. We've had programs flying nearly continuously since the early 80s. The thing is how you deal with the new challenges and how we get more mission out of a given amount of content. Constellation is teaching us again about the cost of a launch. Oh, the shuttle, horribly, horribly expensive. Well, every mission to the moon, I won't quote numbers because I don't know them, you're throwing away 2 massive rockets. Most of 2 massive rockets. We're going to reuse the SRBs. And every mission to the moon is vastly more expensive than a shuttle mission. And so this view that says, well, we're going to get cheap rockets and go do a lot of things, we're still going to be trying to squeeze every bit of mission objective out of every launch. One of the interesting things of this, the fact that we're not building a lunar operation that will last forever, we're going to be in the test flight mode. And if you look at the, okay, well, we're going to get it working and then use it to carry people to and from station. Well, okay, we may fly a couple flights before we actually have to depend on it, and we will depend on it. Well, those are the early operational flights where you learn stuff, you go back, you change the way you operate, you change the flight software to reduce risk, increase margin. Every time you change stuff, you'll have detailed test objectives, which today the shuttle, after flying all of its flights, still has detailed test objectives where you're trying to find a way to control future risk by operating, doing a special thing to see how did that work out. We expect there will be evolution of the systems, and so while we're flying this routine CEV on a CLV back and forth to station, we expect they will be inserting upgrades to make the moon stuff work and try that out. And so the rich environment that having very expensive launches gives you is you will constantly be evolving the thing within the capabilities you have, which means you'll constantly be characterizing the operational performance of the vehicle. So that very much goes back to particularly the Mercury, Gemini, Apollo suite that I had an acquaintance I met years ago who was a launch director for the Saturn, and he said, you know, I said, boy, wouldn't it be great if we had that wonderful operational Saturn vehicle? And of course, in an early station, we were all bemoaning that we didn't have a heavy lift launch vehicle. And my friend said, every one of those launch counts was a squeaker. It wasn't really an operational vehicle. It was a very good vehicle, exhaustively managed with hundreds and thousands of things having to happen just right to make it launch. Okay, well, our commercial satellite launch providers today, they've beaten that down very well. They're constantly working to re-engineer it. To get it to that level, you have to launch a lot, and we're not going to launch a lot. We're going to launch a few and use them to the utmost of their capability. And so that's a thing that is so different from a shuttle mission today. the shuttle missions are well-worn grooves on all the risk control thing, the recurring loads analysis, the shaping of the ascent to protect all of the constraints and criteria that make you the most safe possible ascent and entry. And of course, we learned a few things. We still learn things even now. So we're back into that very rich performance characterization. If you go back into Mercury, the teams that did the operators, there were no professional space operators at the time. It was people that came from aircraft flight test and research testing. And so one of the things that the space station's program struggled because there was not this rich cadre of flight test and vehicle hardware test people, and we had to rebuild it. We got through the station, and so within the NASA community, there's a marvelous group of test and verification people, and we were a part of that team because of the on-orbit assembly that someone was selling off verification things on orbit. Very excited to get back into that business, or at least keep the skills that we've learned alive. Again, going through a very rich and aggressive flight test program to get to vehicles that you can trust to go do riskier and riskier things, like go to the moon.